So till now we have covered basic trigonometry. Uh, then we have covered basics of differentiation, and integration. And in last class we have covered vectors. So you will find like all four of these concepts, basic trigonometry, differentiation, integration, and vectors, useful in this chapter. Not only in this chapter but mostly in all other chapters, and that's why I wanted to cover this basic so that other concept will become easier for you. Hmm. Okay, so okay, so you in between, if you have any doubt, you can stop me. Wherever like you feel you want to ask something, you can stop me and ask. Okay, so now I will start with motion in a straight line. So okay, so now I will start with motion in a straight line, and in today's class I will cover like uh, what is average. First of all, I will cover uh, one second. Like first of all, I will cover like what is distance, then displacement. Here is the displacement. Then what is velocity, what is speed, what is acceleration, and what is difference between average and instantaneous velocity and instantaneous acceleration. Average and instantaneous. Okay, so let's start with distance and displacement. So distance is basically total length of path traveled by any object. So this is the actually this is the definition of distance. It is the total length of path traveled by an object. So let's see, like there is a person A, and it started moving from one place to another place by this given curve, and then it reaches from point it starts he starts from point A and he reaches to point B. So basically the length of this curve, so whatever is the length of this curve is basically the distance traveled by this person for reaching from point A to point B. Okay, so if let's say if he travels in a straight line, mm, okay, so if he travels in a straight line from point A to point B, and the length of this path is, let's say, 5 meters. So meters is like SI unit for distance. So if this person travel from point A to B, so this length of this path, which is 5 meters, is the distance traveled by this person. But on the other hand, there is a displacement. So let okay. Uh, Pujita, do you want to ask something or okay? Okay. Okay, so read notes. Miss, I'm making still making it in proper way. Like I'm trying to add as many questions as possible in notes. So I will share the PDF for notes on WhatsApp group only. Okay. Okay. So when we okay, so distance is basically the length of path traveled to reach miss travel from position A to position B. So okay, so this is the distance. But whereas the displacement is shortest distance between initial and final position. So let's say that person has traveled from A to B following this curve, and then he reached point B. But so this
So,
okay. हेलो.
so
यस.
notes कहाँ से मिलेंगे?
मैं आपको व्हाट्सएप ग्रुप पे पीडीएफ शेयर करूंगा नोट्स के. ओके.
Okay.
ओके. Okay. So now let's look at displacement. So it is the shortest shortest distance between initial and final position. So this person has traveled from point A to point B. So shortest distance we will achieve like only by a straight line, because any other like if you use any other geometry to reach from point A to point B, that will not be the shortest, and the shortest distance is always by a straight line. So therefore sometime we define it as the shortest straight line distance between initial position and final position. So this is the displacement. So let's say, let's take one example. Mm, now there is person which is standing at point A. So he has traveled, let's say, 3 meters to reach point B, and again he has traveled 4 meter to reach point C. So the distance covered is basically the length of path traveled by this person. So that is basically AB plus BC. So distance traveled by that person is like 3 meter plus 4 meter, which is 7 meter. Whereas displacement is the shortest distance between initial position, here is A, final position is C. So since therefore the displacement is shortest distance. So shortest distance is always given by a straight line, and therefore this AC is the displacement of this person. And you can find it out from Pythagoras theorem, because it is a right angle triangle. So it is basically square of 3 square is square root of 3 square plus 4 square, and it is square root of 9 plus 16, which is square root of 25, and which is 5. So displacement is always a shortest distance between initial position and final position, whereas distance is the length of path traveled by a person to reach from initial position to final position, no matter what kind of path he takes, whether it is a circular path, or it is some curve, or it is a straight line. So few more things, like, so distance is basically a scalar quantity. Okay. So when we say we give a distance, we just give the mm, any question is there? Okay. Okay. So distance is a scalar quantity. So in last class we have learned like scalar quantities are defined only by their magnitude, and they don't have any direction. So but on the other hand, displacement is vector quantity. So it has it has magnitude as well as direction. So it has only magnitude, it and displacement has both magnitude and direction. So again, let's we can show it using some graph. So here only, let's say uh, uh, if this, let's say this is the north direction, this is west, this is east, and this is south. So if person has traveled from point A to point B, so basically we can say that point B is 3 meter south to point A. Or if we have to say about point C, then we can say that point C is, here the displacement was 5 meter for between A and C basically. So point C is 5 meter southwest, or if you know this angle, so as I told, this triangle is very important, 3 4 5. So in this triangle, the angle of the like the smallest side is 3 meter. So this angle in front of the smallest side is 37 degree. You will have to remember this triangle because many questions can come from this triangle, because these lengths are like unique, like 3, 4, 5. So this angle is 37 degree and this angle is 53 degree. So since this is 37 degree, this angle is also 37 degree, you know, from basic geometry. So you can say point C is at 5 meter uh, southwest at 37 degree to point A. So when you are telling displacement, basically the direction is also important, whereas if you are telling distance, direction is not important. Mm. So let's take few examples. Okay. Uh, so initially a person is standing at point A, then he has traveled 6 meters to reach point B, and so he has traveled in this direction to reach point B, and he has traveled by 6 meter. Again he traveled back 4 meters to reach point C. So since this is a motion in a straight, see, he has moved in a straight line from point B A to B, and again point B to C, he has moved in same straight line. So of course, using the geometry, you can find out this length is basically 2 meter distance between A and C. So if someone tells like find distance traveled by that person. So if someone asks you to find out distance traveled by that person, then it is like 6 meter. So it will be like first A to B, distance between A to B, and plus distance between B to C. So it is 6 meter plus 4 meter, and it is equal to 10 meter. But if we ask you like what is the displacement of that person, what is total displacement of that person? So if someone asks you what is total displacement, then it is only 2 meter. So, and again, if you give directions like north, west, south, and this as east, there's in this case, the basically C, basically that person has displaced by 2 meter east to point A. So means this kind of questions can come, like simple geometry will help you in solving these distance and displacement questions. So now we'll see some more examples on it. Mm, okay, so let's take this circle. Okay, so if a person is standing at this point, suppose that r is the radius, r is the radius of this circle, and a person is standing at this point. Okay, and this person moves uh, from point, let's say this is point A to point C, such that this angle is 90 degree. So if someone asks you find distance and displacement, find distance and displacement in this case. Okay, so Distance is if he moves along this circle from point A to point C, and this means when he has traveled from A to C, this has made like angle of 90 degree across the circle. So you know that the perimeter of circle, actually total angle, like if you move from point A anti-clockwise and you reach to point A, back to the point A, the total angle made is like 360 degree. And to move 360 degree, we move along the perimeter of the circle, and perimeter of the circle is given by 2 pi r. So when he moves 90 degree, so distance, or total distance he has covered, is basically 2 pi r divided by 4. So this 2 and 4 will give us pi r by 2. So this is the distance traveled by this person when he has moved from point A to point C, because he has moved by 90 degree along the radius of the circle. Okay. Whereas if we have to find out the displacement of point A to point C, let's take a straight. So you know that displacement is basically the shortest distance, and it is given by a straight line. So if you have to find out this distance, so here it became a right angle triangle. Okay. Since this angle is 90, so this length is radius equal to radius r, this is length is also equal to radius r. So their hypotenuse is basically the displacement or shortest distance between a and C. So displacement can be given as square root of r square plus r square. So it is equal to root 2 r, sorry, root 2 r. Similarly, if they tell you, mm, okay, let's say now if this person has traveled from point A to point B, whereas this is the center of the circle, and let's say again the radius of this circle was r, and so now if they ask you to find distance and displacement, let's say distance and displacement. So distance is again the length of path traveled for reach from point A to point B. So this length of this path is basically, since he is moving at a distance of radius of this circle from point A to B, so it is, and since it is making, let's say, 180 degree angle, so you can easily find out that distance is basically total perimeter. So as you know, for 360 degree it is equal to perimeter, like 2 pi r. So for 180 degree it will be 2 pi r by 2, which is equal to pi r. So this is the distance traveled by this person. Whereas if you have to find out displacement, so it is the shortest distance between A and B, or shortest path traveled. So shortest path is basically given by a straight line, which is shown here. So it is equal to r, and r means r plus r gives us 2r. So in this case, displacement is equal to 2r. Let's take one more case with using circles. I'm taking more examples with circle because in exam they ask mainly about circle. So in this case, let's say this person starts traveling from point A and reaches back to point B. If he travels anti-clockwise and reaches point to point B, so since point reaches back to point A, sorry. So as you know that displacement is basically the shortest distance between initial position and final position. But in this case, initial position and final position will be same. Therefore, the displacement of this person for reaching to point A by moving anti-clockwise across the circle is basically 0, because initial position is same as final position. Whereas if we have to find out distance traveled by this person, then this is equal to perimeter of the circle, which is equal to 2 pi r. Till now, anyone has any question? If yes, please type it in chat box, or even if you don't have, please write no, so I can proceed further. Okay, I think none of you have any question, and I think this part was easier only to understand. So now let's take example of this regular hexagon. Okay, so since I told it is a regular hexagon, so every side is equal. So let's say this is A, every side is equal to A, and this angle is basically 120 degree. Mm, okay, so if this angle is 120 degree, from simple geometry we can tell that the this external angle is basically 60 degree. Okay, so this is a regular hexagon. Okay. Mm, just give me 1 second. Mm, hmm, okay, so here we have this regular hexagon with each side is having length A. This angle is 120 degree. So now if a person is standing at this point, let's say A, then he traveled by this path and reaches this point B. So here A is the initial point and B is the final point. And if they ask us to find out the distance and displacement in this case. So as you know that distance is basically total path traveled by this person. So first he has traveled by this side of this hexagon, and again by this side. So total distance is basically A plus A equal to 2A. This is the distance traveled by this person for reaching from A to B. But if we have to find the displacement, so this is the shortest path which is given always given by straight line. So okay, so since it is moving towards B, which is final, I'm showing arrow like this. So if we have to find out this basically displacement is the shortest distance between A and B. So you know that this angle is given by 120 degree. So if we draw a straight line here and one more line here, so from basic trigonometry, this angle is 60 degree, because you know that the line across this straight line is 180 degree. So since this was 120 degree, this distance, this angle is 60 degree, and this therefore this angle is 30 degree. So from basic trigonometric ratio, for this 60, 30 and 90 degree triangle, we can say that this side length, so okay, so this, let's say this point is a C. Okay, so this AC is equal to A. Okay, AC length is equal to A, and let's say this point is D. So AD can be given as AC sine 60, and DC can be given as AC cos 60. So I will just erase this A is the length of or the side of this hexagon. Okay, so AC is A. So AD is, since this angle is 60 degree, AD is AC sine 60 and DC is AC cos 60. So if we have to find out this distance like A to B, we will use now we will consider right angle triangle ADC. So we will consider right angle triangle ADB. So in this right angle triangle ADB, using Pythagoras theorem, AB is equal to square root of AD square plus DB square. So here DB is DC plus CB. DC is AC cos 60. AC cos 60 and CB is basically A because it is a side of this hexagon. So AC sine 60 is basically A sine 60 and sine 60 is root 3 by 2. So root 3 by 2 A and cos 60 is 1 by 2. So AC cos 60 is A by 2. So here you can simply write it as AC cos 60 is A by 2 plus A. So it is equal to 3 upon 2 A. So dB is 3 upon 2 A, whereas AD is root 3 by 2 A. So if you input both of these in this equation, you will find it out. AD square is basically root 3 by 2 A whole square plus 3 by 2 A whole square. So it will give us square root of, so it is 3 by 4 A square plus 9 by 4 A square. So it is equal to 12 by 4 A square. 12 by 4 is 3. So it is basically root 3 A square. So displacement between A and B is root 3 A square. So now you must have understood like why trigonometry is very important, because in this case, like in questions of like finding displacement of a like person travel by some distance, there means you can get n number of questions which will be based on basic trigonometry. So therefore I think you should able to derive or remember most of the formulas or equations which are used in trigonometry. Okay, so we will take this, like this is also one of the most common question which comes in the exam. So like you are like this is the tire of a vehicle, okay, and it is, and this is the ground, okay, this is basically ground, or this is basically a wheel, let's say. So wheel is touching at ground at this point, let's say A. So they will ask you like, then find out the distance or displacement of point A when this wheel will complete one complete uh, turn when it is moving. So if it is moving, let's say, so when it will travel some distance, this point A will reach here. After some point, this point A will reach here. Let's say it has reached this point, then this, and again it will come to this point A. So when this will make a full circle, so it will cover basically the displacement or distance, which will cover the distance equal to perimeter of a circle. So when if such kind of question comes, like when a wheel is moving on ground and there is a point A which is touching to the ground, and when wheel will make one complete rotation, so if it makes complete rotation, then in this, so in previous case what we have seen, like in this case the person has moved across the circle and it has reached to initial position only, therefore the displacement was 0 in this case. Whereas if you see this case here, the wheel is moving on the ground. So when it will make complete uh, turn, like one turn, the point, and when the point will again, it will come in contact with the ground, the wheel will make one turn. It is basically equal to perimeter of circle, and therefore it will be given as 2 pi r. So this in this case, the displacement and can be given as 2 pi r. Okay. Whereas if the wheel makes like half turn, okay, let's say the point A was here in touch, and if wheel makes half turn, so the point A has moved to this point, this top point, okay. And now if they ask displacement of point A, so in this case the displacement is like, okay. So as you have seen that when wheel makes full turn, when wheel makes full turn, so total like distance traveled by that vehicle across the distance, or across this ground, is basically 2 pi r. So when it will make half turn, so total distance will be equal to half of the perimeter, that is equal to pi r. So in this case, if you, but they have, since they have asked us the displacement of the point A on the wheel, so point A has moved from this point to uh, this top point when it has uh, made half turn. So this distance basically is half of the perimeter, that is pi r. Mm, okay, so this distance is mm, pi r. And you know that the perimeter, sorry, diameter of this wheel or circle is basically 2 times that of r. This is the diameter. So again, this has become a right angle triangle. So using Pythagoras theorem, you can find the displacement of point A, which is the shortest distance between these 2 points, like bottom point to top point. So it can be given as square root of pi r square plus 2r square. So this is equal to displacement of point A when the wheel makes half turn. Okay. So any one of you have any question? Okay. Okay, I will okay. I will explain the last question again. So in this question, like there is a wheel, okay, and it is touching the ground at point A, and this wheel is like moving in this direction, okay, because let's say vehicle is, your whole vehicle is moving in this direction, the wheel, or let's say it is only a wheel, okay, forgot about vehicle. Okay, so it is moving clockwise. So initially it is at this point. So now this wheel has made half turn. So when it will make half turn, this point A will go to this point, because or top, and since it is moving, it will cover some distance. Okay, so there are two things you should remember, like since this is a wheel moving, Okay, this is a wheel moving. So this point, since this wheel has made half turn, this point A has moved from this bottommost point to topmost point, like diametrically opposite, because it is a half turn. Because if you have any circle and if you cover half a circle, you will reach diametrically opposite point. Okay, you will reach diametrically opposite point if you move to the if you made half turn along a circle. So therefore this point A has reached to the top of the circle now, and since it has made half turn, so like half turn, so it has traveled a distance of this. So like when this wheel is moving, so let's I will make one diagram for your reference. I think I made more than enough circles. Let's remove some of them. Okay, so let's say initially this is the point A which is touching the surface or ground. Let's say we have one more point here, point B. We have one more point here, point C. So when this wheel will travel this much distance from point A to point B, like in this direction, since it is moving anti-clockwise, if this wheel travel this much distance which is across this perimeter, so in this case this point B will come, and let's say there is one more point here, point D. So in this case the point B will come and it will touch the ground. Again when this wheel will travel like this distance from B to C along the ground, then this case point C will come and touch the ground. So similarly when this wheel will travel half a perimeter, so at half perimeter or half perimeter distance there is point D, okay, on this wheel. So in this case this point D will come and it will touch the ground. So the distance between point A and D here is basically half of the perimeter. because A and D are diametrically opposite to each other. And in this case, the point A will reach opposite to the point D, because since they were diametrically opposite. So when this wheel will cover this distance, which is half of the perimeter from point A to point D. So let's say this is pi r. So when this A point A will cover this much distance diametrically opposite, so point D will, which is point diametrically opposite, it will come and touch the ground. So therefore, this distance is pi r, which is half of the perimeter. And since A and D are diametrically opposite, point A will be the topmost point of this wheel. So now we have to find the displacement of point A. So initially, the point A was at this point, and it has moved basically to this point. So displacement is the shortest distance, and therefore it is always given by a straight line. So we have to find out this distance, which is the shortest distance, and therefore it is the displacement. So we know that point A to D is pi r, because it has made half a turn, and since this is equal to the diameter of this wheel, which is equal to 2r. So if we have to find this distance, or this shortest distance between traveled by point A, so it is basically, we can find it out using Pythagoras theorem, and it is therefore equal to pi r square plus diameter is 2r, so 2r square. So this is how you can find out the shortest distance between initial position of point A and final position of point A. Do you still have doubt? Can you just type it out? So okay. Okay, so I think for like, you miss, there can be many, at least one miss, at least you will face one question from distance displacement in NEET exam most probably. But for that, your geometry part or trigonometry part should be good. If you understand trigonometry well, so there is nothing in like distance and displacement, you can easily solve all those questions. So now we will start with speed and velocity. So before starting, if you, any one of you, okay, I think none of you are having any questions. So okay, I'll just directly start with speed and velocity part. So speed is basically the rate at which objects cover a distance, or you can say speed is basically distance per unit time, or distance covered by an object per unit time. Okay, so this is known as speed. So it is distance upon time, or distance covered by a vehicle or object per unit time. So you can simply write the formula of speed as distance upon time, and speed is a scalar quantity, and it has only, therefore it has only magnitude and no directions. So we generally say a vehicle is moving at speed of 10 meter per second or 20 kilometer per hour. So this is how we define a speed, only with the magnitude. Okay, whereas velocity is basically the displacement per unit time. So velocity is given as displacement per unit time. So as you know that there is difference between distance and displacement. Therefore, velocity and speed are different thing. And here velocity is basically a vector quantity, and therefore velocity has magnitude as well as direction. I just wanted to tell you one more thing in this, sorry, distance and displacement. I will just tell it again. So, so now we have seen various examples. Okay, so when we have seen that like a distance, like the person has traveled from point A to C along this side of polygon, then C to B along this side of polygon, and we have found that the distance, total distance was 2a, whereas distance displacement between A and B was square root 3 into times A. So here in this case the distance was 2a, and displacement was root 3a. So in this case, as you can see, the displacement was lesser than that of distance. Similarly, in case of circle, like when the person has came from same initial position A, traveled across this circle and came back to initial position A, displacement was zero. Displacement was zero, and sorry, here I made mistake. Okay, distance was 2 pi r. Okay, so here in this case also distance was greater than displacement. So if you see all the cases, the only the most of the cases we have seen, displacement is always lesser than distance. Okay, so and if you consider the case of a straight line, so let's say this person has traveled from only from A to B along a straight line. So in, and if the distance was, let's say, 5 meter, so displacement and distance is both same in this case because this person has traveled by a straight line. So in this case, distance and displacements are same. So from this we can come to a conclusion that the ratio of displacement to distance is always less than equal to 1. So this is one of the important ratio, that is the ratio of displacement to distance is always less than equal to 1. So it is less than 1 when, like we have seen the example of circle or hexagon. But when the person has traveled in a straight line from A to B and there is no reverse coming, or it has stopped at point B, so in this case both the distance and displacements are 5 meter, it is equal, both are same. So in this case distance by displacement, displacement by distance is 1. So this is very important thing we can come like ratio, what is the displacement ratio of displacement to the distance, and it is always less than or equal to 1. Okay, so now we'll come back again, we'll again come back to speed and velocity. Okay, Harini, can you hear me now properly, or is there is some issue?
Yes, sir. Now I can hear you properly.
Okay, okay, fine. Okay. Okay, so again we'll come to speed and velocity. So as we have seen, speed is basically distance per unit time or distance covered per unit time, whereas velocity is displacement per unit time. Okay, so you know that distance and displacement are different thing, and therefore speed and velocity are different thing. So here speed is a scalar quantity, it has only magnitude, and vector is a the velocity is a vector quantity, it has magnitude as well as direction. Okay, so again if we have to tell, like a vehicle, if we say a vehicle is moving at 50 kilometer per second, 50, oh sorry 50 kilometer per hour, so then it is basically a speed because we are not mentioning it is like moving in which direction. Whereas if we define the directions like north, south, east, west, and let's say vehicle it as point A, so let's say it is moving towards east at 50 kilometer per hour. This is how we define velocity, where we tell like 50 kilometer per hour east. Okay, and like when you will fix the coordinates axis, like if you are fixing like mm, or let's say mm, you are fixing this as the direction of velocity, this is positive direction and this is negative direction. So in in this case you can clearly say that like velocity, if you say it is 50 kilometer per hour, then of course it is in this direction. If you say it is minus, or if you have to say it is to moving, let's say this positive is towards east and negative is towards west, so if you write plus 50 kilometer per hour, then you can say that it is moving towards east, or if you say minus kilometer 50 kilometer per hour, then it is moving towards west. So in both cases you can see that like velocity can be positive as well as negative based on the like notation or direction you decide, whereas speed is always positive. Similarly, in case of distance, distance is always positive. So distance is always positive, whereas displacement can be positive or negative based on the direction or coordinate axis you define. So let's again, we will consider some examples. So first we will take, let's say, a vehicle is moving from point A to point B, and where point A and point B are 10 meters apart, and the vehicle takes 5 seconds to travel from point A to point B. So in this case, both like distance is basically, sorry, distance is given as 10 meter. If you see the displacement, so displacement is also 10 meter, and time taken by vehicle to travel from point A to B is 5 seconds. So speed is distance upon time, so which is 10 upon 5, and it is equal to 2 meter per second. Whereas velocity is also, velocity is given as displacement upon time. So in this case, displacement is also 10 meter equal to distance and 5 seconds since it has taken. So it is 2 meter per second. So you should also remember the unit of speed or velocity, which is meter per second, because the unit of distance is meter, unit of time is second. So the unit of speed is meter per second. Similarly, the unit of displacement is meter, unit of time is second. So this unit of velocity is also meter per second. So this unit can vary, but since we are using SI units here, both the SI unit for distance is meter, whereas SI unit for time is second. Okay, so okay, let's see one more example like this. I will, give me 1 second. So this actually, this arrow, double arrow, generally we use to specify distance, okay, or to show the dimensions. So let's say a vehicle again is moving from point A to point B, and point A and point B are 10 meters apart. Again, let's say they are 10 meters apart, and in 5 seconds, okay, in A to B, which are 10 meters apart, in 5 seconds, and again it moved from B to point C, and B to C are basically 4 meters apart in, let's say, 2 seconds. B to C, 4 meter. So what is this average speed? So first of all, we will see like what is the average speed and what is the instantaneous speed. Okay, to solve this question, we need to know the difference between both of them. So let's say I am in Mumbai and I am traveling to Delhi. So, and since I'm traveling by train, and consider that it is of course it in train also it is not straight path always, but let's say we are moving in a straight path from Mumbai to Delhi. So here is, we have some railway stations in between. Let's say we have station A, and here we have station B. So from Mumbai to uh, station A, the vehicle was moving at, or the train was moving at 50 km per hour, and the distance between Mumbai to point A or station A was, let's say, 500 kilometers. Then the vehicle or the train w- like stopped at point A for, let's say, 1 hour. Again, the distance between point A and point B is 300 kilometers, and the train was moving at, let's say, 60 kilometer per hour between point A and point B. And when it reached to point B, it stopped for 1 hour. And from point B to station Delhi, the distance was, again it was 500 kilometer, and the train was moving at 100 kilometer per hour for reaching from point B or station B to Delhi. So if we have to find the average speed or average speed of train for reaching from Mumbai to Delhi, so average speed, so it can be given as total distance upon total time. So similarly, if someone asks you to find average velocity, so as you know that, like, velocity in this in velocity, you know that, like, you only consider the shortest distance. So this is basically the displacement, total displacement upon total time. Okay, so in this case, if we consider, if we have to find total distance, so total distance is what? Distance from Mumbai to A, then A to B, and then B to Delhi. So let's say total distance equal to distance from Mumbai to point A plus A to point B plus B to Delhi. So it is equal to 500 plus 300 plus 500. All are in kilometer. Okay, 500 kilometer. Actually, you should always keep in mind the units when you are doing addition. So let's say the total distance was 1300 kilometers. Now you have to find the total time. So what we have learned here is distance is equal, or speed is equal to distance upon time. So for reaching from Mumbai to A, how, if we have to find out the time taken by train to travel from Mumbai to point A, we will say, so this equation, like speed is equal to distance upon time, we can rewrite this as time is equal to distance upon speed. So For reaching from Mumbai to station A, distance covered was 500 kilometer and speed of the train was 50 kilometer per hour. So the time taken by train for reaching from Mumbai to point A is basically 10 hours. Okay. So total, if we have to find first of all total time is like basically time taken by train from Mumbai to station A plus waiting at station A plus station A to station B plus again waiting at station B plus time taken by train to travel from station B to Delhi. So here we have found out that the time taken by train to travel from Mumbai to station A was 10 hours. Then the waiting time at station A was 1 hour. So let's calculate time taken by train to travel from point A to point B. So again we know that time is distance upon speed. So here the distance was 300 kilometer, speed was 60 kilometer per hour. So we get the time as 5 hours. So time taken by train to travel from point A to point B is 5 hours. Again, the waiting at station B is 1 hour. So we'll add this one. And last is calculating time taken by train to travel from point B to Delhi. So distance between point B and Delhi was 500 kilometer. Divided by speed of the train was 100 kilometer per hour. So the time taken by train to reach from point B to Delhi is basically 5 hours. Okay, so we will add this 5. So total time taken by train to reach from Mumbai to Delhi was 10 plus 1 plus 5, like 16 plus 1, 17 plus 5, 22 hours. And total distance between Mumbai and Delhi was 1300 kilometers. So therefore, the average speed it can be given as total distance. Total distance is 1300 kilometer divided by total time equal to 22 hours. So you can simply calculate this 1300 by 22. So if you calculate it, you will get basically 59.09 kilometer per hour. So this was the average speed of the train. Whereas if you consider, like if you go at this point and if we have to find out what was the speed, so at this point this speed of this train was 50 kilometer per hour. At this point it was 60 kilometer per hour. At this point it was 100 kilometer per hour. So if I ask you like what was the average speed from Mumbai to Delhi, you will say it was 59.09. But if I ask like what was the speed at this instant, let's say at this time equal to t, what was the speed of the train? Then you will say it was 50 kilometer per hour. If I ask, let's say this is time t plus some t plus x at time t plus x, what was the speed? So it was 60 kilometer per hour. Similarly, at this instant, it was 100 kilometer per hour. So basically, now you must have seen the difference between average speed and instantaneous speed, but I will talk about instantaneous speed later. First we'll focus on average speed and average velocity for now. Okay, so in this case the average speed was 59.09, and since we have traveled from Mumbai to Delhi in a straight path, and Since it was the shortest distance, the average velocity is also equal to average speed in this case. So it is also equal to average velocity because we have traveled by a straight path. Okay, so now let's come back to this question. So this vehicle has moved from point A to point B in time 5 seconds, and the distance covered from point A to B is 10 meter. Again, it has moved from point B to C, which is C is basically 4 meter towards left of B, and the time taken was equal to 2 seconds. So total distance covered was A to B plus B to C. So it is equal to 10 plus 4 equal to 14 meters. And total time taken, similarly, time taken was also traveling from A to B plus B to C. Here is arrow B to C. And it is not stopping at point B. Okay, so A to B plus B to C, time taken was 5 plus 2 equal to 7 seconds. So therefore, average speed in this case is total distance upon total time, which is equal to 14 by 7 equal to 2 meter per second. Let's find out average velocity in this case. So for moving from point A to C, total displacement if we have to find, so total displacement was basically the distance between distance between A and C. So shortest distance between A and C is basically AB minus BC. So shortest distance between A and B is 10 minus 4 equal to 6 meter. So 6 meter is the total displacement for moving from A to C. And time taken was same only, like 5 plus 2, like 7 seconds, because total time taken for moving from A to C is 7 seconds. So if you have to find average velocity, then it is equal to 6, that is total displacement divided by 7 seconds. So you can calculate it. So we will see more example of average speed and average velocity. So okay, any one of you have any question in this case? Please type yes or no. Till now, like, okay. Okay, fine. Now we will take break of, let's say, 10 minutes. And if you have to go for washroom or want to drink water, you can have that. So we will start at 7:35 sharply. Okay. Okay, so all of you are there, or I think Pujita has yet to come. Vaibhav and Harini, are you there? Can you just type? Okay. Okay, we'll wait for 1 more minute and we'll start. Okay, so in similar way, like earlier, we have seen the example of circle. So if we consider the circle of radius r, and let's say we are moving from point A to point B along this radius of this circle. So if we are moving from point A to point B along the radius of the circle, so in this case, the distance traveled by is equal to, can be given as distance is equal to half of the perimeter, and that is equal to pi r. Whereas if you have to find out displacement, so displacement is equal to the diameter of this circle, so it is equal to 2r. Therefore, let's say the vehicle is moving from point A to point B in, let's say, time 2 seconds. So if we have to find out average speed, so average speed will be pi r upon 2. Okay, that is total distance upon total time. And if we have to find average velocity, is equal to total displacement. So total displacement is 2r divided by total time, that is 2, so it is equal to r. So this is how means they will frame the question based on different geometry. So you just have to remember that average speed is basically total distance divided by total time, and average velocity is total displacement by total time. So you can solve any kind of question, only the geometry can change. So let's say few more questions on this average speed and average velocity. So let's say a particle covers half of its distance with speed v1 and rest half with speed v2. Then find the expression for average speed. Okay, so let's take this. Let's say there is a particle which is moving from point A to point B. Let's say the total distance between A and B, we will show it with, so actually this is how we define the dimension with this. Okay, let's say the distance between point A and point B is D. So the particle cover half of its distance with speed v1. So half of its distance means, let's say this is the point at point C, which is at half distance. So the distance between A to C is 1 by 2 of D. Similarly, distance between C and B is 1 upon 2 times D. Okay, the speed in first half was v1. Speed in first half was v1, and speed in second half was v2. So find the expression for average speed. So you know that average speed can be given as total distance upon total time. So we have learned that speed is basically distance upon time. Speed is equal to distance upon time, and therefore we can write this equation as time is equal to distance upon speed. So time taken by this particle to travel from A to point C can be given as distance upon speed. So distance is basically half of the total distance, that is 1 by, since total distance we have considered it as a d, so half of the distance is 1 by 2 times d, and the speed in A to C was v1. So time, let's say this is the time taken, this time is time t1. Mm, so time from A to C, let's say it is t1, let's say it is t1. So it can be given as distance is 1 upon 2 times t, and speed was v1. So finally we got the t1 equal to d upon 2v1. Similarly, we can use same formula, that is time is equal to distance upon speed, to find out time taken by this particle to travel from point C to point B. So from point C to point B, the velocity speed was v2, and distance is again 1 upon 2d. So let's the we can give this time from B to or sorry, time from C to B, we can write it as T2 equal to, again the distance is 1 upon 2d and speed is v2, and therefore we can write it as d upon 2 times v2. So if you have to find out total time taken by particle to reach from A to B, total time, it can be given as addition of t1 plus t2. So it is basically d upon 2v1 plus d upon 2v2, and just we can simplify it as d divided by, okay, one second. So we will take d by 2 common. So if we take d by 2 common, we can write it as 1 upon v1 plus 1 upon v2. So it is simple math, so we can write it as v1 plus v2 divided by v1 into v2. Okay, so this is the total time taken by this particle for traveling from A to B, and total distance is, you know that from A to B is d. So average speed is total distance divided by total time. So average speed can be given as total distance. So total distance is d divided by total time is d upon 2 into v1 plus v2 divided by v1 into v2. So this d and d will get cancelled, and this 2 times v1 v2 will go into numerator. So you can write average speed as 2 times v1 v2 divided by v1 plus v2. So have you understood this one, or do you have any question in or any doubt? Please type yes or no. Please type yes or no so I can move further. Do you have any doubt in this question? Okay. So we will see the next question. So the next question, a car moves a distance of 200 meter. It covers first half of a distance at speed of 40 kilometer per hour and second half of the distance with speed of v kilometer per hour. Then find the average. The average speed given is 48 kilometer per hour. So they are asking us to find v. So either you can use directly this formula to find out, because it is given as half, but we will go step by step again, so get better understanding. So they have given that car move distance of 200 meters. So this total distance from this point to this point is, this distance is 200 meters. It covers first half of a distance at speed of 40 kilometer per hour. So first half means basically 100 meters. So for first 100 meters, it moves at speed of 40 kilometer per hour. In for second 100-meter distance or remaining 100-meter distance, it moves at speed of
Nucleic acid is not a genetic material. Or genetic material in the living organism. Nucleic acid is genetic material in the living organism. Nucleic acid.
I think your mic is on. Do you have any question or okay, fine. Yes. So in second half, the speed was v kilometer per hour. Okay. So and they have given that average speed is 48. Average speed is 48 kilometer per hour. So we have to find out the v. Okay. So you know that average speed can be given as total distance upon total time. Upon total time. Here we know that total distance is 200 meter. It is already given. Total distance is 200 meters. So we have to find the total time. So here they have given us the velocities as like in terms of kilometer per hour. So we should know the conversion of kilometer per hour to meter per second. So that will help you in many questions. So let's say I write 1 kilometer per hour. Let's say let's see how we convert kilometer per hour into meters per second. Okay. So here we have written kilometer per hour. So if we have a speed of 1 kilometer per hour, so 1 kilometer is basically 1000 meter. So we can write this 1 kilometer per hour as 1000 meter per hours. Okay. Similarly, you know that 1 hour. So it is because 1 kilometer is 1000 meters. Similarly, you know that 1 hour is 3600 seconds. So Similar, so this 1000 meter per hour, you can write it as 1000 meters per 3600 seconds. So if you simplify this, you will get like 0 0 will get, and if you divide by 2, then it will become 5 by 18. So basically 1 kilometer per hour is 5 by 18 meter per second. So now if you have to find out the time taken by this particle or car to move, let's say we will to cover first half. So let's say we again point it out as A, final destination is B, and midpoint is C. So if we have to find time taken by this vehicle to move from point A to point C, we can simply write it as distance upon time. So since we know distance, speed is distance upon time, speed is distance upon time. Therefore, we can write time as distance upon speed. So here one thing you should notice that they have given uh, basically they have given final answers in kilometer per hour. Okay, so I think it will be beneficial for us if we consider everything in kilometer per hour. So therefore, instead of converting velocity, in this case we will convert this total distance as, since it is 200 meters, so 200 meter is basically 0.2 kilometer, and half distance is 100 meters. 100 meters means 0.1 kilometer, because you know that 1 kilometer is 1000 meter. Therefore 0.1 kilometer is 100 meters. Okay, so this, therefore we will write distance as, so distance for sorry, the time travel taken by the vehicle to travel from A to C can be given as distance. So distance is 0.1 kilometer divided by speed. So speed was, in this case it was 40 kilometer per hour. Similarly, time taken by vehicle to move from C to B is, again the distance is 0.1 kilometer divided by speed is V. Okay, therefore total time can be given as 0.1 by 40 plus 0.1 by V. Okay, this is the total time. So average speed, as you know that average speed is total distance upon total time. So average speed is already known. So they have given average speed equal to 48 kilometer per hour. So here average speed is 48. Total distance is 0.2 kilometer, and total time is, here we will take 0.1 common. So 0.1 will come out, and here we have 1 upon 40 plus 1 upon V. Okay, so again this will give us 2, this 2 will cut this 48 and it will give us 24. So if you uh, simplify this, you can write it as 1 upon 40 plus 1 upon V is equal to 1 upon 24, because you have moved this bracket towards left and you have moved this 24 towards right. So you got this 1 upon 40 plus 1 upon V is equal to 1 upon 24. So from that you can get 1 upon V is equal to 1 upon 24 minus 1 upon 40. So that is equal to 40 minus 24 divided by 40 into 24. So 1 upon V is equal to 16 divided by 40 into 24. So we will again divide it by 2, both numerator and denominator will get 8, and here we will get 12. Again, if you divide it by 2, we will get 4, 6, and if you divide 40 by 4, you will get 10. So 1 upon V is equal to 1 upon 60. Therefore, V is equal to 60 kilometer per hour. Let's say if it is there. Okay, it is there in answers. So this is how you can solve the different questions. Please tell me if any one of you have any doubt until now. Please type it so we can move towards acceleration. Okay. Okay, fine. So we will just give me a minute. We will move towards acceleration now. Okay, so we will start with acceleration. Yeah, this is the formula 2v1 v2 divided by v1 plus v2. But remember that it is not always like this. Here, since they have given, like we are dividing the like first half and second, the total distance into first half and second half. So if it was like they have divided it into 1/3 and 2/3, then it may be different. So always better to remember everything from basics. Okay, let's move to the acceleration part. Okay, so acceleration is basically rate of change of velocity. Okay, or you can write it as change in velocity so you can write acceleration as change in velocity per unit time. So we have object A moving, which is moving towards, like, let's say we have north, south, east, west. So at this point, it is moving towards west, east. Okay, it is having velocity of 5 meter per second. Mm. After 5 seconds, let's say it is at point A. After 5 seconds, it has reached to point B. it now in this case it has, let's say it is 5 meter per second east. Now it has velocity of 10 meter per second east. So if we have to find acceleration, so it is change in velocity. So change in velocity is initial velocity, like final, it like change in velocity can be given as final velocity minus initial velocity and upon time, time taken for this change. Okay, so here final velocity was 10 meter per second, initial velocity was 5 meter per second, and so here you know that. Okay, I will just, so final velocity was 10 meter per second minus initial velocity was 5 meter per second divided by time taken was, let's say this has traveled from A to B in 5, oh, let's say 2 seconds, or let's say 5 seconds. Okay, it has moved from A to B in 5 seconds. So time taken was also 5 seconds. So therefore you, it, the change in velocity is 5 meter per second in 5 seconds. So 5 will give us 1. So and the unit of this will become meter per second square. So this is the acceleration, that is change in velocity per unit time. And note that the acceleration is a vector quantity. Okay, so again, whatever we have seen, so it was final velocity, it was basically total change in velocity divided by total time, or it was therefore 1 meter per second square. So again, this uh, average acceleration and instantaneous acceleration, instantaneous, so both terms will be there. Okay, so remember that it is like similar to the velocity, we will have average acceleration and instantaneous acceleration. Because let's say, again we will take one example for this. Let's say we are at point A. At point A, the velocity of the object is 0 meter per second. So this object is not moving. Then it starts moving towards object B at, and at object B, it's at constant acceleration, or its velocity started increasing, and it has reached, when it reached to object B, its velocity was 5 meter per second, and it took 5 seconds to reach from object, from point A to point B. Now it has, uh, let's say, okay, it at point C also its velocity was 5 meter per second, and at point D its velocity, and it took around, let's say 10 seconds to reach from point B to C. It took around like 20 seconds to reach from point C to D, and its velocity at D was 100 meter per second. So if you find its acceleration in between A to B, it was like change in velocity per unit time. So it was 5 minus 0 divided by 5. That it means 1 meter per second square. Okay, so this was its acceleration from point A to B. If you find its acceleration from B to C, then it was like final velocity is also 5 minus initial velocity is also 5 divided by time 10. So it is basically 0 meter per second square. And when we have reached to point D, so it's, so from C to D, its average acceleration from C to D was 100 minus 5, because initial, final velocity is 100, initial was 5 meter per second divided by time 20. So, or let's say for simplification, I will just write this as 95 meter per second. Okay, or let's say this was 95 meter per second. So let's say this is 95. It will simplify our calculation. So it is 90 by 20 means 4.5 meter per second square. So in all three sections, so here the acceleration was 1 meter per second square, here the acceleration was 0 meter per second square, and here the acceleration was 4.5 per meters per second square. So at these three instances, the acceleration was different. So the instantaneous acceleration was different. Whereas if you see the average acceleration, so you can write it as total change in velocity, total change in velocity divided by total time. So total change in velocity in this case is, see, final velocity is 95 and initial velocity was 0. So total change in velocity basically 95 minus 0. And total time is, the total time was like 5 plus 10 plus 20. So 5 plus 10 plus 20 is 35. So, so if you see the average acceleration, so average acceleration is total change in velocity upon total time, which is 95 minus 0 by 35. So it is 95 divided by 35. So 95 by 35 is basically, it is almost equal to 2.71. So meter per second square. So this was the average acceleration. Okay, so questions can come like, so for now we'll just see the average acceleration only. So I will just give you few example of that. So let's say there is a vehicle. Okay, there is a vehicle at point A. At point A, its velocity is 10 meter per second. After traveling, after 10 seconds, it reached to point B and its velocity is, let's say, 80 meter per second. Then find out the acceleration of this vehicle. So you can easily find it out it as change in velocity. So change in velocity is 80 minus 10. Basically, final velocity is given by v, initial velocity is given by u. So change in velocity is v minus u divided by total time, that is 10 seconds. So in this case, it is like 70 by 10. So it is 7 meter per second square. Okay, so they can also give you question similar to this, like in this case, if the this 10-second was not given, so let's say if they give you a question like at point A the velocity was 5 meter per second, at point B the velocity was 10 meter per second, and the acceleration of this vehicle is 2 meter per second square. So find out the time taken by this vehicle to reach from point A to point B. So what is time taken by this vehicle to reach from point A to point B? So you know that it can be given as, so you know that acceleration is given as, acceleration is change in velocity upon time. So final velocity minus initial velocity upon time. So let's write acceleration as a. Okay, so time can be given as v minus u upon a. Here v is 10 minus u as 5 divided by acceleration a as 2. So it is 5 by 2, that is equal to 2.5 seconds. Okay, so they can twist the question and they can ask you anything out of it. So I think for understanding this acceleration, velocity, and uh, distance or displacement, this much examples were enough. I think mostly the practice will make you like help you to improve the understanding of these concepts. So until now, do you have any question? Please write yes or no. Like acceleration, have you understood about the acceleration? Okay, so now I will just give a brief introduction for the instantaneous part, and then we will stop for today. Okay. Okay. So when we say like at this instant, or let's let's say we make something instantaneously. Okay, so it basically tells us like we are talking about very short time period. Okay, so here delta t means time period, is basically delta t is showing time period. So whenever we are telling some about something instantaneous, so we are talking about that thing for very short time. Okay, so in differentiation chapter we have seen the definition of the derivative. So the mathematical like if you have some function, let's say f of x is your function. So if we have to find out its derivative, so derivative of anything is given as f dash of x. Okay, so mathematical definition of derivative was f dash of x is given as limit h tends to 0 f of x plus h minus f of x divided by h. So now let's consider in terms of uh, distance, time, and distance, time, velocity, acceleration. Let's consider in the terms of these quantities. Okay, so here we are finding derivative. So we are finding derivative means what we are doing basically when we like if let's say f of x is equal to x square plus 2x. So f of 1 is equal to 1 plus 1 square plus 2 into 1, that is basically 3. Now we are finding derivative of this function. It means basically we are finding the like what is the change in f of x when there is very small change in when there is very small change in x. So therefore we are taking h as h tends to 0. So h is like almost equal to 0. So x plus h is like very small change from x. So when x changes by very small value h, how much change in this function we are getting? So this is the change in this function f of when we change this x by very small value h with respect to this change. Therefore we are dividing it with h. Okay, so now let's like consider this f of x is basically a, let's consider this f of x is a displacement. So and h is basically a time, so we will write now it as a t. Okay, so when t tends to 0, so now what we are like if we are finding the derivative of f of x is basically we are this f of x plus, so how we will write it as, one second I will write it again, limit t tends to 0 f of x plus t plus, sorry, minus f of x divided by t. Okay, so this is so the derivative of this function, so this function is displacement. So derivative, sorry, f of x is displacement. So derivative of f of x is basically change in, like, so change in displacement with respect to time when t tends to 0. So t tends to 0 is telling us about instantaneous thing. Okay. And you know that change in displacement, or rate of, basically rate of change of displacement, is basically a velocity. So because we have seen velocity is displacement upon time, so when we see average velocity, we basically found out, like, the displacement, and we have divided it with time. So when we see the average velocity, it was total displacement upon time, whereas instantaneous, or instantaneous velocity is basically like change in displacement, or change in displacement per unit time, or rate of change in displacement per unit time, or we can say it as rate of change of displacement. So so velocity is generally given as v, and since it is a vector, we'll write it as a v, and it is basically change in displacement. Since f of x is s, we know that we can write its derivative, so f dash of x as ds by dt. Therefore the velocity is basically differentiation of displacement. Okay. Similarly, if you consider acceleration, okay, now let's consider f of x as velocity. So if f of x is velocity, so velocity is basically rate of change of displacement, and basically you know that this is instantaneous velocity. When you find it out using differentiation, it is instantaneous, because according to the definition of differentiation, this t is tends to 0, like it is, like the time period or over which we are calculating this change in displacement is very short, and therefore it is instantaneous velocity. Okay. Similarly, if you consider f of x as velocity, so, and if you have to find its derivative, f dash of x, so f dash of x will be equal to limit, again t tends to 0, time again tends to 0, f of x plus t minus f of x divided by t. So here, since f of x was, we have considered as velocity v, so what we are finding is change in velocity with respect to time. So change in velocity with respect to time, and here since time is, we have considered is very short, is it is almost tends to 0, so it is, from the definition of acceleration, we remember that acceleration was change in velocity, or initial velocity, final velocity minus initial per unit time. So since here t tends to 0, it is basically instantaneous acceleration, or you can write this f dash of x, or you can write it as dv by dt, and it is equal to acceleration. So acceleration is derivative of velocity with respect to time, and therefore acceleration is, can be written as rate of change of velocity, or it is, so remember that this is, when you write acceleration as differentiation of velocity with respect to time, it is always instantaneous acceleration, because from the definition of differentiation we know that we have considered t tends to 0. Similarly, when you write velocity as differentiation of displacement, you should know that this is the instantaneous velocity. So you know that if you have displacement as s, you can write velocity as ds upon dt, And if you have velocity v, you can write acceleration as dv upon dt. And if you put v as ds upon dt, it will become d upon dt of ds upon dt. So it became d square s upon dt. So in this case, you can see that so acceleration is double derivative of displacement with respect to time. And so this concept will help you in understanding, like in mathematics uh, class, like in basic mathematics, I taught you about maxima and minima. So what we have learned in maxima and minima was, like if you have some function f of x, then if you input its derivative f dash of x equal to 0, then you will get some value of x, and that value will be either maxima or minima or minima. And you have learned that you will take double derivative of this function f dash of f double dash of x, and if f double dash of x is greater than 0 or positive, then it is minima, and if f double dash of x is less than 0, then it is a maxima. So this we have learned in differentiation class. So if you consider f of x as displacement, then f dash of x will be the velocity, and f double dash of x will become the acceleration. And I will teach you like how this maxima and minima you can correlate with this acceleration, velocity, and displacement. And in next class we will learn, I will teach you this part again. I just wanted to give you brief introduction for this class. So do you have any question in this part?
Sir, for acceleration, it is double differentiation of dx square or
It
d
is
d
double.
square s divided by dt square.
Oh,
No,
sorry. Yeah, yeah,
so
yeah.
you have
I
just
yeah.
written ds.
Sorry. It is dt square. Correct. You are right. I think I. Okay.
Okay.
Yeah, yeah. You are right. It is dt square. I forgot to write. Do you have any question in it, like till whatever I have covered?
No, sir.
Harini, are you there? Like, do you have question?
No doubt, sir.
Okay, so I think for today we will stop now, and like I will ask everyone if on weekdays also if it is possible to take class, and if every one of you agrees, then we can have at least one day like in weekdays where we can have a class, because I think covering complete syllabus is very important. So I think I will ask in group like what is the best time for everyone to have class. Okay, so for today we'll stop now, and we will meet mostly on Saturday for this week, but from next week we will have one more day where we will have class. Okay.
Okay, sir.
Okay. Okay, so I will close the meeting. Thank you.
Thank you,
Thank you,
sir.
sir.